Hello everyone, thanks for joining us today and welcome to how White Ops fight cybercrime using machine learning capabilities with Snowflake and AWS. Couple of housekeeping things before we start the webinar. When you join today's webinar, you selected join either by phone call or your computer audio. If for any reason you would like to change your selection, you can do so by accessing your audio pane in your control panel. Also, from this control panel, you will have the opportunity to submit questions to today's presenters by typing your questions into the questions pane. We'll collect these and address them during the Q&A session at the end of today's presentation. If we are not able to get your question, we plan on responding to each of you personally through email. The recording of the webinar will be available after the conclusion of this presentation. So keep an eye out for that email. My name is Srinivas Kesanapalli, Principal Partner Solution Architect at Amazon Web Services, Inc. And I will be your host and moderator for today's webinar. In addition to my introductory presentation on data lakes in AWS, we'll hear from Tamer Hassan, co-founder and CEO of White Ops, Rash Mehta, Senior VP of Engineering White Ops, Munir Contractor, Principal Engineer White Ops, Will Herbig, Senior Manager from White Ops, and Andres, Partner Solution Architect at Snowflake. So we look at data lakes in AWS. As organizations are collecting and analyzing increasing amounts of data, traditional on-premises solutions for data storage, data management, and analytics can no longer keep pace. Data silos that aren't built to work well together make it difficult to consolidate storage so that you can perform comprehensive and efficient analytics. So this limits an organization's agility, ability to derive more insights and value from its data, and capability to develop more sophisticated analytic tools and processes as your needs evolve. So due to these limitations, organizations are increasingly moving towards building data lakes. A data lake, which is a single platform combining storage, data governance, and analytics, is designed to address these challenges. It is a centralized, secure, and durable cloud-based storage platform that allows you to ingest and store structured and unstructured data and transform these raw data assets as needed. So for a data lake, you don't need a predefined schema. You can use a complete portfolio of data exploration, reporting, analytics, machine learning, and visualization tools on the data in place with no data movement. A data lake democratizes your data and make the optimal analytic tools available to more users across more lines of business in your organization. This enables them to get all the business insights they need whenever they need from this single source of truth. A data lake has to be secure, compliant, and auditable, and it should be able to cost effectively scale both compute and storage. Amazon S3 meets all the above criteria. The Amazon S3 based data lake solution uses Amazon S3 as its primary storage platform. It ingests and stores data from a wide variety of sources into a centralized platform, and it basically gets structured data from databases, data warehouses, unstructured data such as your PDF files, or semi-structured data, JSON, CSV files, or binary data. For example, video, audio files. So Amazon S3 supports all these. It builds a comprehensive data catalog to help you to find and use data assets stored in the data lake. It secures and protects and manages all the data stored in the data lake. And also it helps you to use tools and policies to monitor, analyze, and optimize infrastructure and data. You can run your queries on all these data assets in place, and you can integrate your current and future third-party data processing tools as well. So building a data lake and making it the centralized repository for assets that were previously duplicated and placed across many silos of smaller platforms requires implementing stringent and fine-grained security and access controls, along with methods to protect and manage the data assets. A data lake solution on AWS with Amazon S3 at its core provides a robust set of features and services to secure and protect your data against both internal and external threats, even in large multi-tenant environments. With IAM, you can create AWS IAM users, groups, and roles in accounts, and then attach access policies to them that grant access to AWS resources, including Amazon S3. Amazon S3 supports multiple encryption options. Additionally, AWS KMS helps scale and simplify management of your encryption keys. It protects your data. Amazon S3 provides 11 nines of data durability. And also it provides versioning to protect data assets against unintentional and malicious deletion and corruption. For compliance, Amazon S3 cross-region replication automatically and asynchronously copies data assets from a data lake in one AWS region to a data lake in a different AWS region. All of these Amazon S3 features and capabilities, when combined with other AWS services mentioned in the slide, will be able to meet the most stringent data security, compliance, privacy, and protection requirements of your organization. The power of data lake built on AWS is that data assets get ingested and stored in one massively scalable, low-cost performant platform, and the data discovery, transformation, and SQL querying can all be done in place using innovative AWS services. In addition, there are a wide variety of other AWS services that can be directly integrated with Amazon S3 to create any number of sophisticated analytics, machine learning, artificial intelligence, data processing pipelines. This allows you to quickly solve a wide range of analytic business challenges on a single platform against common data assets without you having to worry about provisioning hardware and installing and configuring complex software packages before loading data and performing analytics. Plus, you only pay for what you consume. With that understanding, we'll go over how our partner Snowflake augments Amazon S3 data lake. Snowflake augments Amazon S3 data lake in many different ways. Snowflake has Snowpipe that can listen to the changes in S3 and push the data in Amazon S3 into Snowflake. It has external tables feature that allow you to query data in your Amazon S3 data lake from Snowflake. Your data resides in Amazon S3 data lake, but you can access it from Snowflake. Or you can enrich your data lake with Snowflake using data lake export. Andre's partner SA from Snowflake will go over into the details of this slide, but I'll cover it at high level. At high level, you can connect to data in Snowflake and in your data lake using a Snowflake Python connector, or exported data from Snowflake into your S3 from Amazon SageMaker to train your models. And also, you can basically call, once that model is trained in Amazon SageMaker, an endpoint would be published. And you can call this endpoint from Snowflake using the external function feature. With that, I will pass on to Tamer Hassan from ByteOps.
All right, hello. Let me start with a bit of a trivia question for everyone to think about. I'll ask you, how long do you think it takes to build a skyscraper? And just think about that in the background. I'll come back to why that's important. Before we jump into how we've used Snowflake and what we've built on top of it, I just want to spend a few minutes on how we made our decision and really how a database decision becomes a business decision, as it did for us. That is one of the most important things. As engineers, we often make a lot of technical choices. There's the typical buy versus build, and it's always easy to think about the cost of something and make a decision on the cost of something in terms of time, money, computation, right? And what's often missed, and the most important thing I can leave you with, is understanding the positive value and impact of something on business. And I'll say that the ability for anybody, whether it's an engineer or a VP making a decision, to go from cost to actually positive impact and present the trade-offs is really visible and really powerful. For us, with the database decision and how we build our database architecture, that was about time to insights. How long does it take to understand something? Which is actually really about cycle time. It's about iteration time. And that's where there is a world of difference between being able to iterate in minutes or hours as opposed to days or weeks. This has been made clear in many different analogies in the world, but one of the more stark ones is in building skyscrapers. So it takes usually, typically, and it ranges widely, about 5 years to build a skyscraper. And I remember thinking about this when I studied mechanical engineering. That was my chosen path. I thought about building things, and when you think about building a car or an engine or designing an aircraft, right? When you think about the time it takes, that's your feedback cycle, right? And that's, I think, what attracts software engineers to software, right? You can the fast feedback cycles, knowing the laws of the universe and experimenting. But when we build skyscrapers, it takes us 5 years just to know whether we got something right or wrong. Whether this method over here causes more leaks or instabilities or otherwise, right? In China, that has changed dramatically in the last decade. They have mastered the ability to put up skyscrapers in 2 weeks. And the result of that is Chinese architecture is way beyond any other architecture in the world in terms of innovation and knowledge. And that's because they're not waiting 5 years for feedback loops. And so that was the essence of and the importance of looking at technology choices for us. It actually wasn't about how much does it cost. Any great engineering team, as most of you all know, can build anything that we choose to, right? But that doesn't mean we should. So for us, it's about our inner core is anti-fraud. Where do we want to spend our time? And the impact of moving from other technologies to ones where we can get rapid feedback loops is what did it for us. If we can go to the next slide, please. I always look back on the email I got from one of the reps, Tom at Snowflake. This is while they were in stealth mode. We were among their first customers, I believe the second customer, while they were still building the platform. And I was the CTO at the time. I don't typically respond often to cold reach outs, but I read this one, and essentially the claims of the Snowflake database, that the separation of compute and storage, the ability to use ANSI SQL or standard SQL on semi-structured data, and a handful of other things. And my first reaction was probably the same reaction we should all get when we look at a bumblebee on paper and do the math. Like, it shouldn't fly. It's rare in the database world for things to break out of traditional database theory, and so that's what got us started. And the claims actually translated to, for us, rapid iteration. We are in a game where we have active adversaries, fraudsters, and some other problems in technology. It's about product iteration. but the ability to iterate quickly is actually what does it. And to me, it always comes down to a core principle that I held dear as CTO when making these kinds of technology decisions, is that people time is way more precious than the cost of computation. I would pay dollars any day to save on people time and put people time on our core, right? And oftentimes it's easy to overlook that when you look at the math on a spreadsheet of how much something costs. But there are intangible costs and intangible values in the whole equation. And that was an important part of our decision. I'll hand it off here to Rush, who will walk you through what we built on Snowflake and how we use it.
Great. Thank you, Tamer. And I want to kind of expand a little bit before we go into the how of Snowflake and AWS, and expand a little bit on the skyscraper analogy and turning 5 years into 2 weeks, and put in the context of the adversaries that we're fighting. Right. The core mission of White Ops is to disrupt the economics of cybercrime. Right. And what that translates into is, if you take it first, economics, right? The adversaries that we're fighting against are extremely well-funded, right? And let me give you an example of what well-funded means and why, what their incentive structure is, right? If you look at the tools and technologies out there in order to commit fraud, right? If you're a non-technical user, you can go out there right now, find a browser tool that will record your mouse clicks, insert some credentials from the dark web, and voila, you have automated browsing and you can start committing fraud. That could take hours to days, and it's a few $100 to a few $1,000 of cost, right? Then on the other extreme, you have, okay, I'm going to infiltrate a chip on an IoT device and do some fake clicking and perpetrate millions and tens of millions of transactions across the internet, across different publishers. And then in between, you have malware that gets downloaded side by side to a computer machine. All of those things can cost, thousands to tens of thousands to maybe a few $100,000 to build. The reward for that is millions of dollars to tens of millions of dollars, right? So the margin is ridiculously high. They get to afford really skilled engineers to do what they want to do and adapt and move quickly. So this game is no longer about just putting a really strong padlock on your front door, right? Because in a typical case, you have a home, you have an alarm sign in the front of your home, the crook goes to the next door. First, by principle, White Ops doesn't want the crook to go next door. We want to stop that crime. Two, if you got such a well-funded adversary, that padlock is going to get busted next time they show up on your block, right? And that's the adversary we're fighting, right? There's massive scale, it's lucrative, and they move fast. And we have to do the same. So I wanted to set that stage and talk about a little bit about how our customers use our technology, and then go into a little bit of the architecture. So if you're our customer, what do you have to work with? There are two modes if you're an advertising customer that you get to engage with the White Ops technology. First is a passive mode, which if you look at the detection tag, we give you a detection tag, which is a JavaScript tag that you deploy either in an iframe or on your on a web service, hopefully on the top level. And we collect signal, send it back through our White Ops detection signal. And it takes usually a few minutes to process the decision. Then we make that decision available however you need through some data ingestion mechanism. We have a dashboard, and we also have mechanisms by which you can get data if the dashboard isn't enough, or you have a preferred mechanism. Like, for example, we recently launched secure views in Snowflake, where if you're a Snowflake customer, you can get the decision right there, and you don't even have to change technology stack, right? And the passive mode is it collects a lot of signal, usually about 1,500 plus signals are passed through the passive mode. On the flip side, if you're in a pre-bid environment and you want to prevent the ads, fraudulent ads from going to any perceived fraudulent endpoints, you can do an active connection to our server. The customer collects the signals themselves, usually a lot fewer, on the order of magnitude of dozens, connects to our active API. We make a decision, send back a bot or not decision, for which the customer can then decide how they want to react to that. But we also make that same decision available through our data ingestion mechanisms that we talked about before. All right, so it's a super high level how the technology interacts from a flow perspective. some of the insights, we have lots of rich insights we provide. This is just some examples. If you're an advertising customer, you likely want to know what domains or what websites have the highest level of IVT and where they're coming from. If you're in our marketing program, you generally want to see not just domains, but the source and the campaigns that have a high level of fraud. And if you're on application integrity, which is more a product, you'll likely want to know what events are causing the register the most fraud, like login registration and those things. And again, you can go beyond the dashboard into whatever mechanism you desire to get the data that you need. So that's the product at a high level. And to re-engage, what does this mean for the product, right? So if you think about, there are two problems that we're trying to solve for when we're trying to build this product. One, we have a technology and algorithms that we need to deploy to work at this massive scale, right? We talked about millions of infected machines, millions of infected potentially IoT devices, server farms, well-funded adversaries, right? They're not sending any of our customers a small amount of transactions. And on the second side, we have to be able to take all of that information and then look at it and be able to adapt our capabilities really quickly. So if you look through the pipeline that we have two pipelines. The top is the passive pipeline, the bottom is the active pipeline. The passive pipeline is built on, and as well as the active one is built on AWS. We use a lot of the AWS capabilities for multi-availability zones across multiple regions for resiliency, logging, monitoring, deployment, you name it. It has a variety of tools that fit a variety of our use cases to make sure that we can operate at scale with resiliency. We see about, in our passive pipeline, about 1 billion decisions a day with our current customer base. That translates to, in our staging environment for that S3 bucket, about 8 gigabytes a minute, which has to get into Snowflake. On our active pipeline, we see about 1.4 trillion transactions a day. And our active pipeline, just a nuance there, we actually have to be where our customers are. So this is multi-cloud. And the reason is because that decision of bot or not has to be made usually within 5 milliseconds. We offer a 10 millisecond SLA, but we like to try to do it as fast as possible because this affects some really high performance transactions on the ad side. So that active pipeline is usually co-located, but then also sends the information back through a set of S3 buckets, about 1.5 terabytes a day. That is all aggregated and has to be available in Snowflake per transaction, as well as aggregate levels to be available to our analysts, as well as our customers through their reports and dashboards. We were at a point where we're getting that information through the pipeline within 4 hours. Now we're usually around the 20-minute mark, and Munir will talk about that in a second. But the reason that that's important, so I just talked about the first problem. How do we operate at scale? The second problem, how do we react to adaptation? There are two ways. We have a data operations team that needs to look at the information in Snowflake and make sure, like, even though our algorithms are catching a lot, are there things we're missing? Is there a quick adaptation? Is there slight changes? Can we make a mitigating change into our pipeline really quickly, right? And the faster we have that in Snowflake, the faster that we can change the structure of the signal we collect and use it in unstructured fashion in JSON and Snowflake, the easier it is for our analysts to be able to use that and react to it, right? On the flip side, our data science team runs a lot of our data science algorithms and updates our models. And usually we update our model every 4 hours within the pipeline that you see here, right? And you can see some of the other stats, just as a quick hit, we have about 2 petabytes of data in Snowflake, and our analysts, as well as some of our automation tools, run about 200 queries a day, right? So that's a really high level on the overall flow. Again, 2 problems: operate at scale, move quickly at scale. And that's just how these technologies work together to solve that. So with that, I'm going to hand it off to Munir for some details.
Hey everyone. Okay, so we'll walk through a simple of how our architecture was set up and is set up into loading into Snowflake, just to highlight some of the flexibility that we have with using AWS and with using Snowflake as well. So when we started off with a pretty simple batch ingestion architecture where we had an EMR cluster that would fetch data from Kafka in every hour and put it into S3, and then we had a separate process, a cron job, that would just fetch the new files from S3 and upload them into Snowflake using Snowflake's copy command features that allow us to directly send data to Snowflake from S3. with this pipeline, we had a latency of about 90 minutes, a P95 latency about 90 minutes from sessions arriving on our edge servers to finding those in Snowflake. This was generally fine, but as time progressed, we realized that actually 90 minutes is actually way too long for us. Like, we need to have a much shorter latency if we are going to improve our bot detection and respond to active threats as soon as they come in. So we had a long project around how we can redesign this to make this faster. Eventually, we settled on an architecture which involved using Kafka Connect, a Kafka API that allows us to put micro batches into S3. So we essentially create files that are roughly 80 to 90 megabytes compressed, and they go into S3. This 80 to 90 megabytes number was decided because Snowflake recommends using less than 100 MB, so we settled with something that was 80 to 90 megabytes. And then once these files are in S3, we have an SQS notification that goes directly from S3 to the SQS queue. The SQS queue is then polled every 10 minutes by Airflow as soon as there are new messages to consume, which invariably there always are. So those new messages will then get pulled into an Airflow DAG, and then the new DAG now uploads all of these files in parallel to Snowflake. So at peak, we can ingest something like 4,000 of those S3 objects in parallel in Snowflake. So this allowed us to bring down the latency P95 down to 20 minutes for a majority of our traffic. There was certain traffic that will exclude from this, but yeah. So we had this gave us a lot better response time to threats that would come in. Also, our detection and analyst folks could now look at data as soon as it came into the servers a lot quickly from when it came into the servers, and start changing anything that they would need to in their analysis or research more quickly than they could before. Okay, and then let's briefly talk a little bit about what is this data, right? So early on, we made a very simple decision that we want a very, very simple payload. It's all one large JSON. There is no schema or anything attached to it, because we wanted the flexibility of being able to collect specific signals based on where the tag is running and what kind of environment we are operating it, without having to overcomplicate things in our collection and in our payload essentially. So this is where I think Snowflake really shines. It's like you can use this unstructured JSON blob and still run SQL on top of it, giving you the power of all the features that come up with a relational database. So the way we deal with this is we take all the raw signals that come in through our payload and keep the payload, but at the same time, we also have the ability to flatten them out. Like, some of the more commonly used fields from the payload are flattened out into a separate table to improve performance on things like customer reporting and queries that are run more frequently. Like, so this is, I think, one of the key differentiating features of Snowflake is, like, we have this messy unstructured data, and then it stays as is, and you can use it as it, but at the same time you can nicely transform it into a structured full SQL relational database, and then use all of that with it. And with this, I'll hand it over to Will for some case studies.
Thanks, Munir. We wanted to talk through some of the real world examples of how we're using the massive scale that Snowflake provides. And one of the biggest examples of this is TERRACOTTA. This was an operation that we took down this past summer. Some background on this attack. This was an app spoofing operation. So what was going on is there was a shoe app that it was advertising that if you sign up, give them some information such as your address, your email address, some things like that, then in 2 weeks, they're going to send you a free pair of shoes. And sounds too good to be true, and that's because it was. Ultimately, the shoe was a lie, and they were not sending anyone shoes. What they were doing is, embedded in this SDK, there was an Android WebView launcher, and in the background, they were generating these ad calls, and they were pretending to be many other apps. As we note here at the bottom, they were spoofing about 5,000 apps, and this is pretty much anything you can imagine. Money management app, fitness apps, video downloaders, any kinds of things. They were pretending to be anything and everything. Over the course of the operation, they infected about 65,000 devices, so pretty large scale, and it was generating around 2 billion bid requests per week. You can do some quick mental math there. 2 billion bid requests per week, 65,000 devices. That means each device is generating something like 30 to 50,000 bid requests per week, which is a pretty astronomical amount of traffic for one single device. So coming back to something Rush mentioned earlier, when we are doing preventative analysis, when we're trying to make sure our customers don't bid on pieces of traffic that are lower quality, we have much lower amounts of data. Munir was just talking about how in our full payload of 15,000 data elements, in this preventative context, we only have about 20 data elements. So when fraudsters are spoofing some of these pieces, it makes it even harder for us to accurately predict whether or not something is fraud or not. And that takes us to the kind of novel approach that we took here. So what we were able to do is we were able to create entities. These are going to be semi-unique identifiers, and we have about 100 million of these per day. And then we could statistically represent each of these entities. That is, we're going to statistically summarize their behaviors and technical elements. And from there, we're going to analyze a matrix of these. So we're going to compare each individual entity to each other individual entity. So 100 million by 100 million matrix, that's 10 to the 16th pairs. That's an astronomical amount of data. And what we can do from here is we can identify the consistencies and anomalies between all of these different entities on a statistical level. And we can identify what about this attack is statistically anomalous. And from here, this very novel technique, this very computationally intense technique, allowed us to take down the TERRACOTTA operation and prevent about 90% of its attack from going on. And fortunately, we were able to work with Google and get some of these apps taken off the Play Store. All right, one other thing Rush mentioned is that we're always trying to find new pieces of fraud. And a really powerful technique that we have is information asymmetry. There are many things that we know about our data that our fraud counterparts don't. So a very simple example here is city distributions. So this comes from an operation we were doing on some Nigerian apps, where on the right here, you can see that in this specific app, most of the traffic was coming from Lagos, and that's roughly what you'd expect, considering that Lagos is the largest country in Nigeria. And you can see a kind of a long tail here of many other cities that are going on. So what we can do is we can compare the app traffic that we expect against this actual distribution and find an anomaly score here. This is called this chi-squared analysis for those of you that might remember statistics. And what we can do is we can do this on a massive scale. So in this example, this was the target app we were looking at, and almost 100% of the traffic was coming from Abuja, which is not a populous city in Nigeria. And that is extremely anomalous. First of all, it's anomalous for one city to be the entire portion of traffic for a given app. But second of all, for a city to be this statistically anomalous in this context is very abnormal. So we're doing this at an absolutely massive scale. So for each individual app, we have about 500,000 apps. We can calculate these distributions across 50 different variables. And then from there, we're doing further statistical techniques such as normalizations. And from here, we can really quickly identify what are the most anomalous apps, what are the most anomalous types of operations that are going on, and we can prioritize our analysis this way. And again, this is at a scale 500,000 apps, 50 different distributions. These are scales that we couldn't do if we weren't enabled by Snowflake. And this comes back to collective protection, which is one of the really core concepts here at WideOps. So right now we have about 10 trillion interactions per week that we make decisions on. And that is a massive scale. That's something that allows us to have a global view of what we're looking at. When it comes to the Eve takedown, which is the largest ad fraud botnet to date, this is again a scale that Snowflake enables us to do. We really wanted to not have this be a game of whack-a-mole. Rush was giving the example of how, if you change your lock, they're just going to go somewhere else. We didn't want that. We didn't want to try and take down their mechanics and just have them try a new piece of ad fraud. That's why we were able to work with the FBI and bring long-term consequences for many of the cyber criminals that were involved in this operation. At the end of the day, when we have all of these customers, what we want to do is we want to make integrations easy. And that is why we are proud to announce that as of today, WideOps is now available at the AWS Marketplace and the Snowflake Data Marketplace. So with this integration, we're able to make easier procurement of our devices and help many more people adopt our technology. And we can help bring insights to many new customers with this type of integration. And with that, I'll pass it over to the Snowflake team.
Thank you. This is Andries from Snowflake. So Snowflake's platform is built on top of AWS, and what Snowflake does is actually eliminates data silos by being able to ingest data from various data sources or actually connect to data on the S3 data lake. And then we provide basically access to all users with no contention to the data on top of Snowflake, all the data consumers and users of that. So Snowflake focuses on various different workloads, but today I'm just going to focus on primarily the data lake, how Snowflake augments the S3 data lake by providing access and actually very performant access to the data and add an additional layer of security on top of that. And then as well, Snowflake actually enables data science and actually provides a lot of unique features that makes data science a lot easier to deal with by using Snowflake. And another very unique feature that Snowflake provides is the ability to share data without the need for data movement. So it's basically available in real time to other Snowflake customers within the ecosystem. So if we look at the Snowflake integrations with AWS and specifically S3, so Snowflake integrates with various AWS services, whether it's Glue, MSK, EMR, etc. But I specifically want to draw into Snowflake's integrations with the AWS or S3 data lake. So the first thing is we provide what we refer to as external stages, which just basically creates a direct connection from Snowflake to the customer's S3 buckets or prefixes that allows us to either very easily ingest data from S3, as was discussed today, but we can also export data or unload data to S3 in various formats, including using data lake exports, so it actually uses the same partitioning scheme and data file formats that's needed within S3. The other integration point that we provide that's very powerful is the ability to map external tables on S3 data, where you can then directly query those tables or that data on S3, whether it's structured or semi-structured data files within Snowflake, and you combine that with data that sits on Snowflake as well and actually join those. And then for data that has to be frequently accessed or you require an additional level of performance, you can actually create materialized views on top of those external tables that's automatically managed by Snowflake, and it provides you performance similar to native data within the Snowflake databases itself, which creates a lot of performance and opens up a lot of possibilities within managing data or doing analysis on top of it. The next point is what was mentioned earlier as well, is a service that we provide called Snowpipe. If you have data pipelines that land data within S3, Snowpipe will automatically monitor the S3 location, and as new data lands on S3, it will automatically ingest and load that data into Snowflake to make it much more seamless to be able to get access to the data within that. The next area is in terms of integration with SageMaker. So we have a Python connector that allows SageMaker or data science within SageMaker to get direct access to Snowflake and then view data within Snowflake or the external tables that will be mapped out to S3 and build out from a notebook experience in terms of like if they want to do feature engineering, etc. They can do that from within Amazon SageMaker. And then if you want to do training on very large data sets, you can simply issue a command to Snowflake, where Snowflake will unload the data into a specified S3 location. SageMaker can then run the training models on top of that. And similar with batch inference calls, you can do very large batch inference calls by unloading data to S3 and get the results back and automatically load it back into Snowflake. An additional feature that was made available from a Snowflake perspective is what we refer to as external functions. And the value of that within the machine learning ecosystem is as you build these SageMaker models, you deploy that as an endpoint, and now you can directly access those endpoints from within Snowflake. And that allows business users to very easily get access to various machine learning models to enrich the analysis. So you can now run potentially a dashboard that not only queries existing data within Snowflake, but in real time get inference from these machine learning models to enrich let's say, a dashboard or report that they need to get access to. Another customer that we want to mention is specifically Portland General Electric, where they had various challenges with a complex architecture because they have various systems where it's traditional relational databases and applications to much more complex IoT type data and systems that they had to have access to those systems and get performance with that. So they had issues in terms of the ability to actually store the data, get performant access to do analysis on that, and that became a very costly exercise for them around that. By leveraging Amazon S3 Data Lake, what they were able to do is they were able to actually land the data with an S3 by either using the AWS database migration service or ETL partners like Matillion to land that on the S3 Data Lake that I had. And then from there, the data was either being accessed by Snowflake or using external tables. And in some use cases, what they were able to do is actually ingest the S3 data into Snowflake, actually process the data and actually export it back into Data Lake to make it available for various other applications around that. And that enabled them to provide a lot of value to their end customers as well, where they can now save an enormous amount of money in terms of licensing costs as well as labor time saving. And it also, what they were able to start doing is actually share with their partners and consumers, share data within Snowflake to make it easily available to them. And we also will invite you to actually get more information on Portland General Electric on the Snowflake Data Cloud Summit that's currently ongoing. With that, we'll go to a live poll. And the question here would be is what Snowflake and AWS integrations and features are you interested in learning more about? And we'll do a live poll. So there's a number of features that we focus here that we kind of mentioned is one is external tables that allows you to actually directly map S3 data into Snowflake and give you direct access to that. Materialized views that specifically in the S3 case can give you high performant access to that S3 data. And then similarly, external functions that allows you to call from within Snowflake to various AWS services and specifically SageMaker model endpoints that we can look at. And then other features is specifically around the Amazon SageMaker integration. And we'll then actually invite you to join the reInvent sessions that will be in December. There will be some exciting announcements around that as well. And next will be around data sharing from a Snowflake perspective. We'll give a couple more seconds for people to see which one of these integration points or features they would like to learn a little bit more about. And I think we're almost ready with the poll answers. So it looks like a couple of features that of a lot of interest is the Amazon SageMaker integration as well as data sharing. So thank you very much for that. And with that, I'll hand back control to Srinivas.
Yeah, thanks, Andres. We are now transitioning into our live Q&A. As a reminder, you will be able to submit any written questions through the questions panel. In the event that we're not able to answer your questions today, we'll follow up with everyone individually via email. With that, let me take a look at that questions coming from our audience. The first one is to Andres. How can we use Snowflake to improve speed of access to hard data stored in our S3 data lake?
So by using external tables, you can map to the data on S3 and to provide access, especially for frequently access and high performance needs to access the data. The materialized views would be the way to use. And you can create materialized views in various ways. Is one, you can actually create a materialized view that even includes aggregations that can, for a specific type of query, can provide a lot faster access to that. In a lot of cases, you can just map a straightforward materialized view. So potentially in a case of, let's say you have JSON semi-structured data and you find you may use some fields within that. More frequently, you can specifically call those fields out as well. So it'll make predicate filtering a lot faster on that.
Thanks, Andres. I think this is for a White Ops team. Can you describe a little bit more about the availability of White Ops in AWS and Snowflake Marketplace, how that can be used?
So availability of white ops in AWS and Snowflake Marketplace. From an availability, I'm assuming you mean what zones and availability setup do we have for the various technologies. For our passive integration, we are multi-region in our front end on our API technology. In US, we're in multiple regions, and we're also in Europe. For our core detection capabilities, we're primarily multi-availability zones, I believe, within Northeast. And for Snowflakes, we're also in the Northeast. We are planning to, for our passive and for some of these other places, go to multi-region. But for our active solution, we're right now in multiple cloud providers in many regions and many availability zones.
Oh, thank you.
Good question.
Yeah, the next question we have, I think it is to Snowflake, Andres. Can you write user-defined functions that makes a REST call? If so, do you have any samples that you can share? Andres?
Yes, so you can, if you look at a UDF, you can use UDF to actually call an external function that then will be, so basically what an external function does from a Snowflake perspective, it actually, you set up basically a relationship with the API gateway, the AWS API gateway that you can then use to actually make the REST calls from there. And you can look at a Snowflake documentation. There are some samples of how to set it up. It may not be specific to a REST call itself, but it'll probably give you the base building blocks of how to be able to do so. Thanks,
Andres. So this is, I think this is to white ops team. When do you use Snowflake versus a OLAP-based solution like Apache, Droid?
Hi, Munir, do you want to answer that, or do you want me to take it?
I can answer it. So we at White Ops have both Druid and OLAP. A little bit of why is purely historical. So our dashboard is currently uses Druid as the backend for making its data and visualization queries. And that Druid database, the Druid data is actually fed from Snowflake. So we have jobs that copy data from Snowflake into Druid. The reason is purely historical. We were very early on starting with Snowflake at a point where our dashboard, we just, the dashboard just wasn't responding fast enough. And over time that has evolved. And currently we are actually thinking of moving our dashboard over to Snowflake from Druid. So between like OLAP DBs and say Snowflake, I would say it falls down to whether you actually need an OLAP DB or do you need a full SQL engine for reporting and everything. Like performance, early in the early days, yes, performance was an issue, but I don't think it is an issue right now. So it purely falls down to what functionality you need out of that data store and what response times and latencies are acceptable to you.
Yeah, thanks for that. I think this next one is also for White Ops team. What are some tips or lessons learned you could share after building and refining your solution on Snowflake and AWS?
So one thing I know from a very high level from where I sit, one of the things that we keep talking about is cost for performance, and how do we make sure that as we have to work through this massive volume, both the egress and storage costs don't overwhelm us. And obviously one of the ways you do that using AWS technology is using auto scaling wherever you can. However, one of the things that we learned is that auto scaling with such a massive technology for Kafka queues, where the messages are stored where blocks are stored on the file system in a specific way, being able to bring up and tear down within a narrow window of time isn't always effective from an SLA perspective. So one of the things we're playing with right now is how do you work through how many nodes do you have at a minimum? Can we look at diurnal patterns, things like that, in order to be able to ramp up and ramp down with more variability, so we don't have some parts of our pipeline that are static.
Yeah, thanks for that. So next question to Andre is from Snowflake. Do external tables only support Parquet format, or can we build them against other data formats such as CSV, JSON, or XML?
So Snowflake supports external tables or semi-structured data in various formats, including Parquet. We support JSON, XML, CSV, and a few other formats as well, which makes it very easy to work with Snowflake mapping your external tables because we don't limit you in terms of the file formats that we support.
Thanks, Andres. Before you go away, I think the next question is also yours. So I think you answered it, but somebody asked again. So how does the external tables work? Is the control plane resides in Snowflake and data plane in customer S3? Could you go into details?
So how external tables work is you have to set up a storage integration from Snowflake to the customer's S3 bucket, and then you will map the external table basically from Snowflake. So basically what will happen then is when you execute a query on the external table on the Snowflake side, it will read the data from the customer's S3 location. So the data still resides and is basically the source of the information. And then Snowflake will just read the data in from there into the Snowflake's computational area to actually service the query.
Thanks, Andres. And the next is also along the same line. So can we materialize the data that is read by external tables into Snowflake?
Yeah, so I think there's probably a couple of angles to that question. So one is with materialized views, you can actually materialize the data within Snowflake, and it's in a more optimized format to provide faster performance. But as you make changes in S3, Snowflake will automatically update that information. And then similarly, what Snowflake can do is, and that's what a lot of customers do, is you can actually be able to take that in, if you, let's say you read a semi-structured format, you maybe want to optimize it a bit more, you still have the capability of then exporting that data back into a different location on S3 to make it available to other types of services or processes that you might want to run.
Thanks, Andres. I think with that, we don't have any more questions from attendees. If you think of something, please let us know. After the webinar, we can get back to you. Thanks, everyone, for joining today's webinar. And please don't forget to fill out the satisfaction survey after the webinar. Thank you.